15. So this is number 15 and number 16. Number 15 talks about scientific notation. Now, scientific notation is something that that you've seen I think out of 5th grade, and I believe I knew we talked about it in 7th grade, but it is something that comes up often that students don't remember because it's not something that we harp on over and over again. So we're going to choose the answer that best approximates 3 to the 20th in scientific notation. Now, there's several ways that I could go about doing this. Quite honestly, the way I would attack this problem would be by using a calculator. I know 3 to the 20th is going to be a ridiculously large number. So the last thing I really want to do is multiply 3 20 times. But apparently that's what I'm going to have to do on this calculator. So here we go. 3 times, and you're going to count the 3's for me. That's 1,
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
All right, now I am benefiting here from having a calculator that has a very large ability to show numbers. So our answer has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, most calculators do have, well, all graphic calculators would have a 10-digit capacity. Many scientific calculators do as well, but we need to convert this into scientific notation. So what I'm going to do is I'm going to write this number out. So we have 3, 4, 8, 6, 7, 8, 4, 4, 0, 0. Now, my decimal point is right here. To turn something into scientific notation, I will have a decimal number here, and you can see that up here they have they don't go more than 1 decimal place. And then we're going to multiply it by 10 to some power. So I'm going to be playing fill in the blanks here. So my next step is to go ahead and count how many decimal places I need to move to get the decimal point right here. So if we go 1, 2, 3, 4.
5, 6, 7, 8, 9.
So that means we're taking 10 to the 9th power, because we have to move this decimal place over 9 spaces to get that 3 over here. So I also know we're going to have a 3 over here. Now the question is, if I'm putting one number here, is it appropriate to put a 4 or should I round? Well, if you think about it, this number is gigantic. I'm going to put it in the commas so that we can read it a little bit better. So we have hundreds, thousands, millions, billions. So this is 3,486,784,400. Now, my question to you is, if we round up, is that a lot bigger than if we don't? I mean, in other words, would you be willing to take $3.4 billion or $3.5 billion? So what would you rather have? 3.5. So we will take a look at this. This is more than 5, so it's going to mean that we're going to have to round this up. So we end up with 3.5 times 10 to the 9th, which is an option right here. Now, negative exponents don't give you negative numbers, they give you fractions. So this is used for numbers that are very, very small. So if you're talking about the size of pieces of an atom, say how large a nucleus of an atom is, you'd be using scientific notation to show something very, very, very small. The other thing scientific notation is great for is showing numbers that are really, really, really big. So if you wanted to talk about how far the sun is away from the Earth, you wouldn't want to write it out in standard numbers. It'd make more sense to write it in scientific notation because the distance is gigantic. So for number 16, use the answer that is closest to 2.575 times 10 to the 6th. Great. So the first thing I'm going to do is I'm going to write this out, 2.575, and then we're multiplying it times 10 to the 6. So I'm going to go 1, 2, 2, 3, 4, 5, 6. So in normal notation, this number is 2,575,000. So we need to come up with one that is closest. And to be honest with you, the easiest thing that I can think of would be to test these numbers out and see if they're close. If we get something that's fairly close, then we're going to stick with it. If we don't, then we'll move on to something else. And I realize the easiest and shortest one to work with is going to be 12 to the 6. So I'm going to start there because it's easiest to do. I just have to multiply 12 6 times. So we have 12 times
2, 3,
there's my third.
4,
There's 4.
5, 6.
All right, so this one gave us, my pens are really being obnoxious. We have 2, 9, 8, 5, 9, 8, 4. Put in my commas, so there's that one, and I'll put a blue spatch here so I know that that's what I'm doing. So my next one, I think we can probably get closer. I'm not sure, but let's give it a shot. So our next one that would be the next easiest would be 11 to the 9th. So let's do 9 11s. 1,
2, 3, 4, 5, 6, 7, 8, 9.
That's way too big. That's not even in the ballpark. Obviously, if I had a graphing calculator, that would make life much, much easier. Or a scientific net calculator that would be able to take something to a different power. My calculator is not able to do that, so that's why I'm stuck doing it repeatedly. So we know this is not right. I'm pretty sure 6 to the 12th is going to be pretty ridiculous as well. And I'm suspecting that 2 to the 18th is going to be gigantic as well, because we learned in our investigations that the exponent has the biggest impact on how big the numbers get. So 2 to the 18th, I mean, that's the only one that I can think of that would be that might work. So let's try it, but again, I think it's going to be way off base. So help me count.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
That's ridiculous. Kind of how this kind of is what we were talking about. When we know that the exponents are super big, we get ridiculously big numbers. So at this point, we can say with fairly good certainty that 12 to the 6th is going to be the closest answer. So we'll stick with that.
Okay.
Okay.